Lesson number 2 in our unit on transformations is going to be on rotations. So let's start with our definition. What is a rotation? Well, a rotation turns a figure, didn't have a large enough blank here, turns a figure around a fixed point called the center of rotation. The figure rotates at a specific angle and direction. And the directions will be either clockwise or counterclockwise, and I'm going to abbreviate that with CCW, counterclockwise. And what we have to do is just remember where our image maps to depending on what the degree of the angle is and the direction of the rotation. So I'm going to fill these in for you now. If I have a 90-degree counterclockwise rotation, what's going to happen is XY is going to map to negative YX. And yes, you do have to memorize these. If I have a 180-degree rotation, XY will map to negative X, negative Y. And if I have a 270-degree rotation, XY will map to Y, negative X. Got to remember those. Okay, let me say a word about the direction, clockwise or counterclockwise. If you should be asked a question, let's say the problem was to rotate something 90 degrees about the origin, and you're not given the direction. If the direction is not specified, then you're going to always rotate counterclockwise. Why is that? Because that's the way we measure angles. If I asked you to sketch in here a 45-degree angle, you would sketch in something like this, I'm going to assume, right? That's 45 degrees. We always measure our angles in a counterclockwise direction unless instructed to do otherwise. So if you're presented with a problem and the direction is not specified, then you're going to assume that it's the standard direction, which is counterclockwise. Let me also point this out, that 90 degrees counterclockwise would also be the same as a 270-degree clockwise rotation, and a 270 degrees counterclockwise rotation would be the same as a 90-degree clockwise rotation. And how about 180? Doesn't matter whether I specify the direction or not, because clockwise or counterclockwise, that's going to be the same. So you better make yourself a flashcard. If you're one who's stopped making your flashcards, you definitely better make yourself one with these rules so you'll remember them. All right, so just like last lesson, you might want to pause here, and for the next 3 problems that we're going to work together, go ahead and sketch in your pre-images so we can move right along. First one we have here, the question is, how do I rotate this about the origin? So I've got triangle ABC with the given vertices. I want to go 90 degrees counterclockwise, so that's the typical direction that we want to go. So we have to remember our rule. The more times I write this, the better I will become at remembering it. So we might as well write it every time we work a problem. So what I'm going to do then is I'm just going to take my pre-image points and I'm going to do this transformation here on them. So if X maps to negative Y, then that means A prime is going to be negative 7, 2, right? X maps to negative Y. So negative Y would be negative 7, and then that's going to become my X value right there. So that's how you apply that rule. Okay, B is 6, 5. So it's going to become, going to take 5, make it X, make it negative. So that's going to be negative 5, 6. And then C will map to negative 1, 4. So let's come over here and draw our new triangle. A prime is negative 7, 2. 1, 2, 3, 4, 5, 6, 7. 1, 2. A prime. B prime, negative 5, 6. 1, 2, 3, 4, 5, 6. And C prime is negative 1, 4. So there is my rotated triangle. And let me show you a little something here. I am rotating about the origin here. You see this? I'm rotating, oh yeah, that says that right there. I'm rotating about the origin. So if I were to put my vertex of the angle of rotation right here, and I were to sketch in the side of the angle to C and the other side of the angle to C prime, we can see that I do indeed have an angle of rotation of 90 degrees. And the same would be true if I did the same process for all the other vertices. You would see that the same is true. Each vertex has been rotated 90 degrees. How about triangle XYZ? We have these vertices and we are rotating 180 degrees. So let's remember what our rule is. If I'm rotating 180 degrees, xy maps to negative x, negative y. That makes that fairly easy. That means x prime is going to be negative 3, 2. Y prime is going to be negative 6, negative 1. And z prime will be negative 5, 7. So let me come sketch this guy in. Negative 3, 2, 1, 2, 3. There's x prime. Y prime, negative 6, negative 1. There's y prime. And z prime is negative 5, 7. So there is our rotated triangle. All I did, guys, is I applied this rule right here to find my new vertices. And you can see that if I did the same thing that I did above, if I draw one side of my angle of rotation to x, the other side to x prime, I do indeed have an angle of rotation of 180 degrees. And the same would be true, of course, for the other vertices of the triangle. And finally, one more. I think you should pause right here and do this one all by yourself. Come back, check to see how it went. All right. I wrote my rule here for a 270-degree counterclockwise rotation. XY maps to y, negative x. So for G, for instance, I have to switch x and y. So I know that G prime is going to be, the y has to come first now, so negative 2. And if this were any number besides 0, it would be negative x, but negative 0 is the same as 0. So I can see that that's how I'm going to go about finding my image points. I do the same for h prime and I prime, and I get the vertices you see there, and then I did sketch in the transformed triangle. Our next lesson will be on symmetry.